Hello, everyone. I think we'll make a start. I don't think everybody's quite logged in yet, but we'll give them a few minutes before we actually get into using SolidWorks. So let's have a little talk about what we are going to do today. So I'll just share my screen. You should be seeing my SolidWorks interface there. And I wasn't planning on doing this today, but I think on reflection we will have a little go at modeling the part that you can see on the screen. So this is a plastic injection molded cycle tool. So it's a tire lever essentially for changing tires on a push bike. So I think what we're going to do is we're going to follow a JPEG file, which is available on the learning materials. So hopefully you can see the learning materials for the course there. So professional engineering practice, learning materials, SolidWorks is the subfolder that we've been working in. We've done some basic extrusion and revolve work. I think we did last week, the little bit more practice at using those tools. We use the shell tool, a fillet tool there as well. So just getting our practice in terms of using the sketching mode, all the different options, blind depths, up to next, through all. So yeah, we've had a little practice at using some basic tools. But I think what we'll do this week, as I say, is we'll take a JPEG from down here. So there's a section a little bit further down the menu that's called Practice Parts. And if you click on that tire lever JPEG file and just view that, what you get is a screenshot of an engineering drawing of that part. And I think it'll probably be most useful to everyone if we take this part from the part modeling stage. So we're gonna model it as a part model, which again will be developing some of the skills that we've already covered. And then when we've got the part model and it's finished, we'll save the part model, and then we'll use that part model to create this engineering drawing. So we're learning a little bit more about the workflow in SolidWorks, and ultimately when we finish this sort of short module, you should be able to model simple parts and then create simple engineering drawings of them. So yeah, that's what we're aiming for. How far we get through that process in this tutorial that we have today is sort of a little bit unknown. I would expect us to finish the part model and get some of the way through the setup of the drawing. But wherever we get to, we'll take a save of everything today, and then we'll come back to it and probably just complete the drawing next week, and then maybe have a look at something else that we can create a drawing from. So this is one of the skills that we want to try and build up. As well as creating the parts, we want to be able to create engineering drawings of them like this as well. So so if you want to get that on your screen as a reference, what I was doing just before we started was putting together a little sort of step-by-step screenshot-based guide for this. And I think what I'll do, rather than try and upload that now and sort of cut into our session, I'll upload that after the fact, so you've got that to refer to. But that's a really simple little guide. I've tried to make it as pictorial as possible. So there's a little bit of text in here, but there's a lot of sort of screenshots showing the steps that go into creating this thing. So you can zoom into this. I'll save it as a PDF and upload it right at the side of the actual JPEG file that we're working from. But essentially, this is going to be our workflow today. So I'm going to keep this off screen, and then I'll keep pulling it in onto the screen just so that we can see where we're going. But essentially, we're aiming for this as our finished part. So it's just a case of using most of the sort of modeling skills that we've already used and applying them to creating this form. So you've got to kind of come up with a strategy to tackle this. There's various routes that all lead to an eventual model that looks just like this, but you've got to try and break this model down into simple elements and model it in the kind of most logical workflow. But you don't have to think about that at this point because I've sort of done that thinking for you. So we'll go through it piece by piece. So the first thing, before I get rid of this document for a second and we actually get into SolidWorks, hopefully you can see I've written here boss extrude and it's a thin extrude, which I think we covered a little bit of last week when we created extruded boss bases, but we simply created them from a single line, and the system added a thickness of material onto one side of that line. So we're using that same skill here. And all I've done for reference here is just taking a little screenshot of what the sketch looks like. So you can see there's a 100mm line, there's another line coming off at an angle here, and the angle is referenced to the base plane there. So that shouldn't be too difficult for us to create as an extruded boss base. So let's just pull that onto my other screen, and then obviously you can see I've got this tile lever finished, but I'm going to go in as if I was you and I was just starting afresh. So let's do that now. I'll just save this one and shut that down and probably save that as well. I'm just taking this back to where you will be, which should be there. So we want to create a new part file, so we're going to click on the sheet of paper looking icon at the top, the new part, new file dialog, and then if we want to double click on part file, and then again I'm not going to go over the sort of methodology of hiding and showing your base planes. Hopefully we've kind of mastered that by now, but if not, you can always go back to the other tutorials after this. But what are we going to do first? We're going to create an extruded boss base. We have to make a decision on what plane we think we're viewing the tile lever from. I've made the choice that this sketch is going to go on the right plane because the view that we're kind of viewing it from, or the orientation that we're viewing it from, I class that as the side of the actual part. So right plane. So if you want to click on extruded boss, click on the right plane, your system will rotate your view round, and this is a simple just two-line sketch. So I'm going to get the line tool, drop one end of my first line onto the origin so it locks itself on there, and then click. I believe, if I remember rightly, this one was 100mm long, so I'm going to try and get it approximately 100mm, about there. Then I'm going to hit escape, because the next line that I'm going to draw, I don't want it attached to the end of this one. So then I'm going to go back into the line tool again, and then I'm going to draw my second line out from the origin at an angle like that. And I think the length of this one is around about 60. So if you try and hit somewhere near 60, about there. And that's it. That's the sketching portion done. The next thing I'm going to do is put some dimensions on it. So I'm going to use my Smart Dimension tool, and then I'll dimension the length of the horizontal line to be 100, and then I'll dimension the length of the angled line. So given that this is an angled line, there's a few different ways of adding this dimension. You can see mine has sort of defaulted to giving me the length of the line along the angle. But if you move this dimension around, you can see it behaving slightly differently. So you can dimension an angled line relative to the horizontal and vertical directions as well. So you can see that. So just have a little play with that. That sometimes trips some people up. But in this case, we're going to actually want to dimension along the line itself, so the actual length of the line parallel to the line. So it's that one that we want. So if you click there to drop the dimension, and then this one should be 60 mil. And then I've still got the Smart Dimension tool. And the last one that I'm going to do is an angular dimension, and I'm going to reference it to this plane. So the plane that is vertical there, the front plane, I'm going to click on that, and then I'm going to click on the actual line itself. And again, don't click on the midpoint there. You could see that the midpoint's just appearing on that line. I want to click on the actual body of the line itself, and then place that dimension. And this one is going to be 62 degrees. So when you get to that point, your sketch should be fully defined if you've done it as I've done it there. It's a little bit hard to see the majority of that line, but that's just because we've got the base plane visibility on. So we'll just double check. Yep, it is fully defined. The system's telling us it's fully defined down there. So we can exit that sketch. OK and exit, which is the blue icon, as we've done before. And then the system will rotate our view around so we get a better view of what's going on. We can then rotate our view if we want to rotate it to a slightly different viewpoint. And the width of this is going to be, so we can have a look at our reference drawing just to find out. So here's our reference drawing. So the width, just reading this drawing that we've got, is going to be 30 mil. So you can see that there. So you don't have this step-by-step document, but you do have this engineering drawing. So if you want to get that up on your screen just as a reference, that might be good. So yeah, 30 mil, and I would regard it wise in this instance to put one of our base planes down the center of this part. Because whilst this part isn't 100% symmetrical about the center line, it is largely symmetrical. There's only this cut at this end that breaks the symmetry. So it would probably be useful if we ended up with one of our base planes running horizontally on this view down the center of our part. So for that reason, I'm going to change my extrude to a mid-plane. So I don't want a blind extrude, I want a mid-plane extrude. So I sandwich that right-hand plane down the center of the part. And then the last thing I need to do is just change that 10 millimeters to 30. And you should be looking at that. The one thing that I have kind of glossed over there, but it's worth covering again, is the fact that we created an open sketch, and so the system has had to activate the thin option there. But in this instance, for this particular shape that we're creating for this part, that's a perfectly valid way of doing it. There's no problem really with that. You're using the thin feature as a time saver so that you don't have to create extra lines in your actual sketch. So that's perfectly valid. A double check, has that thin been applied at the right dimension? So it defaults to 10 mil. And if we just bring our drawing back in, yes, the thickness of our part is 10 mil in that direction that the thin is applied to. So that's okay. So we can okay the extrude there. That's what we end up with. And then, again, if we just have a little look at the part, so there's an order to these remaining features that is wiser than another order, which doesn't make a great deal of sense to people who don't use SolidWorks very much. But what I'm trying to say here is there's things such as this fillet on this edge here. So you can see that indicated on that section view. So it's a radius of 5 mil. Now, if I was to put that fillet in right now, it could potentially cause me problems when I try and create this cut here, or maybe this cut down here, or maybe this sort of island on the top. So there's a little bit of thought that has to be put in at this point as to what the wisest order of features is going to be. how is it best to create them? Which one is it best to create first? Which one second, third, fourth? And there are certain paths down which you realize that you've created a feature and you've created it in error. It needs another feature to go in before it. So again, just have that in mind as you're trying to break down a part that you've been given to model. There's an optimum order to do the features in. Now again, thankfully, I've already done this part model once, so I've made these mistakes already, and you can get the benefit of that. But it is just worth keeping that in mind if you're giving a pre-existing design to model up in SolidWorks rather than creating it yourself from your own design. But anyway, so the feature that we're going to tackle first is these big round sections on either end of the part, which is just a fillet feature, but in this case, it's a special type of fillet. So it's a fillet that you can apply to 3 faces, and the fillet basically looks at the first face, the second face, and the third face, and it deletes that middle face. That second face gets deleted and replaced with a radius that spans the other 2 faces. But all of that will become clear when we actually activate it here. So for this particular fillet, we don't want to click on an edge because this fillet gets applied to whole faces. So what we're going to do is we're going to go up to the feature bar at the top, click on the fillet icon, which is there. So if we click on the fillet icon, and then have a look at the different types of fillet. So there's what I'd consider the default type there, which is the one that the system tends to default into if you don't make any other selection in here. Then there's a variable fillet, which we haven't used yet. So that essentially, you can see from the preview icon there, that's kind of describing it. It allows you to, say, set a fillet at 5mm at one end of the fillet and then 10mm at the other end. So as the fillet progresses along an edge, it gets bigger and bigger and bigger and bigger. And you can then reduce it. So along the length of an edge, you can have a fillet that gets bigger and then reduces back down again. So that one's quite useful in certain situations where you need sort of a tapered end to a part. There's another one here, which is a face fillet, which is a slight variation of the one that we're going to use. And then there's the one that we are going to use in this particular example, which is a full round fillet. So if you activate that icon, then you can see that your selection boxes underneath change slightly. So 2 things happen. The ability to set a radius for this fillet disappears. So this fillet calculates its own radius. The user doesn't have any input as to what radius of curvature this fillet can be. Whereas in the original type, you can see we've got that ability to set what the radius curvature is. So this one, as I've already said, just requires 3 faces, a starting face, a sort of center face, and then an end face as well. So in our case, the starting face, the top one, is going to be that face there. The mid face, so I'm just clicking there to activate that middle box, or the center face, it's going to be that one. And then if we rotate around to the other side of our part, the final face set in this box here, so I'm just clicking again, it's going to be that one. And as soon as you click there, you should get a preview. Now, if you're not seeing a preview, it might be that you've got partial preview or no preview active. But if you want to activate full preview there, you should be able to see what it's doing. It basically looks at the 3 faces that you've clicked on, and as long as the center face, so this one highlighted in purple, is in contact with the other 2 faces, it calculates what size of fillet it will need to fully bridge the gap between the 2 outermost faces that you've selected. So essentially what it does, calculates the size of fillet that it needs to bridge that gap, and then it deletes this center face and replaces it with the fillet. So yeah, it's quite useful in instances such as this, where you don't want to manually set a radius of curvature. You just want it to adapt to whatever width your part happens to be at. So it allows you to edit your part in a manner where this fillet will always adapt to that change in size. So we're happy with that. We'll click on OK, and then we'll put a second one of those full round fillets in as well. We're going to do this end of the part in exactly the same way. So if we click on fillet again, we should drop straight into the full round fillet type, because the fillet tool tends to keep the last selection that you made within the tool. So until I create a new part now, the fillet tool will stay in this full round fillet mode. So again, we'll do this end of the part. So we'll pick that face there. The center face will be that one there. And then if we rotate round, the third face or end face will be that one. And if you've got the selection right, you'll get the preview like that. And that is it. So we've done the two end fillets. So back to our diagram. What are we going to tackle next? So I think probably we'll cut out this material from this end. And just before we begin, if I zoom in as best I can there, so you can see on the detail view here, so this is just an enlargement of this section of the part. There's some information there, and if I remember rightly, the two lines that are used to create this cutout shape are just a portion of a circle. So there's an arc there, which is that section, and then a straight line attached to the arc there. And there's a tangent relation between the two of them. And then obviously we've got some dimensions just holding all that in place so that we can create our extruded cut through the part. So let's just create that. So if we go to extruded cut, we've got a decision to make now. What plane do we want to create this sketch on? So I think in this instance, given that we're trying to centralize everything around the right hand plane, I think I'd make the choice to sketch this on the right plane and then extrude cut in two directions outwards from the plane. But it would be perfectly valid to sketch on that surface there. So you could sketch on one outer face of the part itself, and then you could extrude cut in a single direction then, just straight through the part. But I think given experience, it's less likely that this right-hand plane will change in the future, whereas that face of the part may get replaced or may get redesigned in some way in the future. Therefore, my sketch that I place on it would not work anymore. So just for security and for ease of modification of the part later on, I think I'd choose the right-hand plane to put this sketch on. So we'll click on the right-hand plane. We have to rotate our view around, as we've said before. The system doesn't do that by default. I think at this point, I think we're far enough into the sort of lessons that we've used SolidWorks long enough that I will just break off there and we'll try and set the behavior of the system so that it always rotates your view so that you're looking normal to every sketch, because that's my preference. I've actually reset my system to the default just so that it's as near to the ones that you're using as possible. But let's see if I can remember how to set that option. So if you just want to pause what you were doing for a sec, you don't have to make any selections or exit. You just want to go up to this top menu. So the top menu bar, if you're not seeing it, it's because you've got the pin option there, unpinned. So if you want to, just hold on a minute. I've inadvertently clicked on something there that I didn't want to. So if you want to click on the pin icon there, that menu should stay open all the time. And then if we go into the tools menu and all the way to the bottom of the menu, so you may have to click on this arrow at the bottom to get all the way down to the bottom of the menu. and then options there near the bottom. So if you click on options, and the options in SolidWorks are many, so there's many submenus here, and it's all a bit confusing when you first start using the customization options within SolidWorks. But there's a brilliant little tool to help you find what you're looking for. So the thing that we're looking for relates to the normal to action when you create a new sketch. So we said, what do I do with the update to Instant 3D? Do I just download it off the link it gives me? Ooh, that's a good question. I'm not entirely sure. Instant 3D. So yeah, Instant 3D should just be an option. I'm not sure it needs an update. Ah, right, okay. So your version of SolidWorks may be constantly sort of checking in and just checking that there aren't any sort of hot fixes and patches and things like that. So if possible, during the lesson, I would put off the mandatory update, if possible, if they'll allow you to boot up. I would accept it, but not during the lesson because it may take you out of SolidWorks temporarily. So yeah, hopefully that answers that question. But if it isn't a mandatory update, then yeah, maybe they will force you to apply it before you can kind of use SolidWorks. So yeah, my preference would be don't apply it right now, come back to it later. Yeah, it's fine so far, but I notice I don't have some of the options you have. Ah, right, okay. Ah, yeah, so that would answer that. So if it's just the instant 3D options, that's not such an issue for what we're doing today. But yeah, certainly I would do it, but possibly do it outside the lesson time. Just let it run whatever updates it needs. So yeah, back to what we were doing. So the option that we're looking for relates to viewing sketches normal to. So what you can do is you can type one of the phrases up here that you're looking for. So I'm going to start typing normal. And you can see that as I start typing it, it filters down all the options in all these menus to the ones that happen to include the search term that you're actually typing. And if we just look at the three, so I can instantly see it's this one. So it relates to when you're creating a sketch. So it's likely to be this one because this one has the sketch as one of the options. And if you read the description of it, auto rotate view, normal to sketch plane, on sketch, and then it's cut off the word creation at the end. So that's exactly what we need. So if you click on that, it takes you to the submenu and highlights the option that you want to switch on. So that's really good. Even I forget. I've been using this for many years, and even I forget where all the options are. But as long as you've got some sort of search term in your head, you can just put it in there, and it will take you to where you need to go. So from now on, my system, every time I create a new sketch, it should rotate the view round to view it normal to. It won't do it for this one because I've already begun this particular one. I'm in the middle of creating it, so I'm going to have to manually apply the normal to option on this one. And then if we just recap what we're actually trying to create, the little shape that we're going to create, it's this little scoop here, which I've already said is a straight line down to that point there. So where these construction lines meet each other, that's where the straight line ends. And then there's an arc, so there's a portion of a circle there up to the end point. So that's what we're trying to create. So let's create the arc first, because I don't think we've used the 3-point arc tool, or any of the arc tools for that matter. But there you can see there's a sort of semicircle there, semicircular arc. It's got 3 points on it, and if you hover over it for long enough, you get a little animation underneath showing you what the clicks are going to do. So that's the first click on one end, that's the second click on the other, and that's the third click, setting how much curvature it's actually got, the arc itself. So I'm going to select that tool, and then what I'm going to do, I'm going to temporarily hide my base planes because they're sort of overlapping some geometry that I want to add a relation to. So they're not being terribly useful at the moment. And the quickest way probably to hide your base planes is just to click on the eye icon, and that will hide all geometry that isn't actually solid material. So if you just click on that, they'll disappear. And then what I want to do is the first point on this arc, I want to lock it onto the point that's highlighted there in orange. So that point on the end of my part where the top face and the upright face there meet each other. That's where I want the first end of the arc. And then I'm going to click somewhere around about there, I would say. And then I'm going to set the curvature. So my third click sets the curvature of this arc. And I'm going to let it default to about there. So that's, you can see there's two what look like construction lines appearing when I get to there. And what that's indicating, they're not actually construction lines. They're just for my reference as the user. It's telling me that when I get to that point, my arc has gone through a quarter of a circle. So it's saying there on the readout, 90 degrees. So it's just indicating that that's a special arc. It's swung through 90 degrees. As it happens, that's around about what I need. It isn't exactly what I need, but I'll probably click when that appears like that. So I don't need the arc tool anymore. So I'm going to hit escape to get out of the arc tool, drop into the straight line tool that we've used many times before, click on the end of my arc because I want to lock this line onto the end of the arc. So click on the point that's on the end of the arc there. And then as soon as I click, you can see I get some yellow lines appearing. Now I've moved too much there and they've disappeared, the ones that I wanted. But there was one specifically that was firing out of the end of this arc. Now I've really ruined it. So let me get back into that. So there you go. There was one firing out of the end of that arc. If I can make it reappear again. It's not going to reappear. What I was going to say is that that was indicating that the line that I was drawing was tangent to the arc. So that's approximately tangent. But it doesn't matter. If you don't have those icons, if you don't have the tangency relation that will pop up, or if you can't see the dashed yellow lines that I initially had, it doesn't matter because we can manually add that tangent relation in a second. What does matter is that you lock this end of the line onto the top edge of the part there. So make sure it locks itself onto the top edge of the part. Make sure you see the little coincident icon in yellow before you click, like that. And then there's one last line. Because this is an extruded cut, I have to create a closed boundary to get it to cut the material away. I could use the thin, but it's a messy way of doing this, and it's prone to problems when you use it in this way. So it's better to close this boundary back up. So I'm going to go back to where I started from with one last line, and then hit escape to get out of the tool. You might have to press escape twice. So that's what I'm left with. Now what I'm going to do is I'm going to put some dimensions on that. So let's see if I can get this on the screen at the same time. Yeah, I think that's working. Yeah, it's not disappearing. So let's get the Smart Dimension tool and we'll put a 25mm dimension, as you can see, on that horizontal top edge that we've just created. So if you click on that, place your dimension, 25 for that one. Then we've got a 5, so there's a 5 down from the top edge of the part there, down to the transition point between the line and the arc, so that would be that one. And that's 5. And then the arc itself, it's saying, is a 10mm radius. So if we just click on the arc itself there, we'll get a radius dimension and then place that. Set that at 10. And you can see, so at this point, our sketch is still somewhat underdefined. That top edge is fully defined, and the points on the end of it are as well. but everything else is still showing in blue. So as we've said before, if we click escape and start trying to drag our sketch around, it's a good tool to investigate how is it still free to move? Why is it still underdefined? So if we just click one of the points, you can hopefully get a sense for how this thing's still free to move. Essentially, the angle between where our arc finishes and where the line begins has no kind of definition to it. It can go to almost a right angle at this side, so you can see that happening there. That's almost forms a right angle, to a very sort of shallow angle, and then through to we're on our way to becoming a right angle in the other direction. So essentially we need to tell the system something about the transition point. And what we're going to tell it is that that arc, so if we click on the arc and then hold down Control and click on the line, are tangent to each other. So you can see that quick access toolbar pops up. One of the first relation icons that it offers us is the tangency icon. And again, if you miss that quick access toolbar, it's down there on the left as well. So whatever relations are applicable to the two things that you've clicked on, it lists here. So tangency is the one that we want. And then when we've selected that, if you just click in some empty space, just to quickly shut that menu down that you were getting there, that relation add-in menu, you should see that it looks as if we've fully defined it now. And you can even try and drag it out position, and it shouldn't let you. So yeah, again, good practice adding our own manual relations in. It's good to have that skill as well as just letting the system add them in as you sketch as well. You need to be able to add them yourself. Just as a little side note, I mean, if you want to do this as I do it, so you can just delete relations. I'm not sure whether we've covered this, and it seems obvious, but it's worth sort of specifically stating it, that if you want to delete relations, just click on the icon and press the delete key. So you can see that coincident relation there isn't actually required, because the combination of the rest of the dimensions and relations eliminate any possible movement for that point. So it's a combination of this length and the fact that that line is being held in a horizontal orientation, and the fact that that end of the line is locked to that point there. But anyway, you can delete relations, so I'll delete that one as well and just prove that it has been deleted, yes. But in this instance, we don't want to delete them, so I'm going to click on undo and get them both back. Well, maybe not that last one, because it's not really required. But yeah, you can delete relations, you can add relations, you can let the system add them, and then you can change your mind afterwards and think, well, I want to delete some of those that the system added and add my own ones in. So yeah, it's all editable, I suppose is the word. So we're happy with that sketch. It's fully defined, and it's I just covered up the chat window there. Let me get it back into the chat. So we've discussed the mandatory update. If the sketch is fully defined already, have I done something wrong? So you've correct. Yeah, you've seen what you did. Yep, never mind. Was there a code for the session? I'm still waiting on my login to generate the codes. So yeah, my higher ups have assured me that they're sending me the login details, and they still haven't done it. So I will get on to Sarah and see if she'll send that to me. What's this saying? I already had the tangency relation. Yes, if you create the sketch in a certain manner. So let me show you an example. I'm just going to create another sketch over here that I'm going to delete before I exit, but it's just to illustrate the point. So if I created some form of arc like that, and then I was smart as I was creating a line off the end of it, then the tangency relation would instigate itself as I was sketching. So you can see that there. So just from slight differences as to where you place your line versus where I'm placing mine, they can't both be exactly in the same position. You may happen to hit the point where the system puts the auto relation in for you there. But yeah, that's a good example of that. So yeah, you were just lucky and I was unlucky, or I was trying to chat at the same time and sketch, and I wasn't making a very good job of it. So when we're happy with it and we've got something that looks like that, we'll click on OK and rotate our sort of viewpoint round so we can see what's happening. And then I already said what we'll do is we'll send this sketch in twin directions, or we'll send this extrude, sorry, away from the sketch in two directions. So if you want to think about it as from our perspective there, we're going to send the sketch backwards into the scene, so that way, and we're going to send it forwards towards the camera, or towards where we are viewing it from. And the option that we're going to use is through all, but through all in both directions. So I think we talked a little bit about the through all option. It can be a crude tool because it will just travel to infinity and just keep cutting through faces of your part regardless. It won't stop. If there's a face there, it will just cut through it. And then if there's another face there, it will cut through that one as well. But in this case, with this particular part, and crucially in this direction, so I probably wouldn't do this along the length of this lever, but seeing as it's going front to back, if you want to call it that, or from one side of the part to the other side of the part, I'm happy to use through all. And if we just selected through all, the normal one, you can see what's happening there. It's just traveling in a single direction away from the sketch. So what we want is through all, but in both directions. So through all both has that sort of effect. And it does appear to stop here, but that's just because the maximum width of our part currently, it knows, so it doesn't travel any further. But if our part was to get fatter, this thing would travel all the way through it. So that preview looks like what we want. So if we click on OK by clicking on the green tick, that should be what we get. So that's our cutout. So what are we going to tackle next? I think we'll put, so I'll just go to my little storyboard. I'll see if I can get that shown. So I think the next thing that I decided to put on was these 5mm standard fillets down either side of our part. So you can see that we've used those sorts of fillets before. They're just the standard type, just the set radius, and you can click on an edge and they will just apply themselves to that edge. So let's put those on quickly. That should be a quick job. So if you click on the edge that you want to put them on, so that edge, for example, one of the icons that appears will be the fillet tool. So there's the fillet tool. You should get a preview of what it's going to look like. That's way too big. So mine's currently set at 10mm, and this should be 5mm. And then rotate around to the other side and add a 5mm one onto the other side as well. So that's relatively simple. And we had a look at the fillet tool before. So yeah, you can set the radius there. The edges that you've collected through your clicks are displayed there. If you click something in error, you can get rid of it by either, you can actually click on the item again. So you can see that I'm selecting that bottom face, and then by clicking it a second time, it's becoming unselected. That is, it can be a little bit sketchy that at some points you try and click to deselect a face or an edge and it actually clicks on a second face, so you've got double the problem then. It's far more stable to right click up here and just select delete from the box. But yeah, technically you can use that option as well. But for this one, we just want the two edges that are running down the length or the spine of our part. So when we've got them and when we've set them to 5mm, you can click on OK for that feature. So you can see they've been added to the outer edges. And then the next piece. So we're going to tackle the sort of racetrack shaped island that sticks out of the top of the part here, which again, we're not using features for that we haven't kind of tackled before. It's just a simple extrude boss base, but obviously some of the sketching tools or some of the relations we may not have used, although I think we have used them all. I think we've used the slot shape in the sketch, and I think we've used the center point slot as well. So yeah, but it's good to practice them anyway, and we do need them for this part. So extruded boss is what we're creating. So if you click on extruded boss, it's asking us what face we want to sketch on. For this feature, we kind of want to choose the top face there because we're going to reference the depth of this extrude relative to that top face. So we kind of have to sketch on that top face just for ease of use. And you can see as soon as I click on that, my system is now set to auto rotate. So it auto rotates round to view that surface or that sketching plane normal to the plane, which is a much less time consuming way to have the system set up. So it is good to set that. And the sizes of this, let's just have a little look at the reference. So here we go. It's that sort of slot shape or racetrack shape. It's 50mm long. It has a dimension there that's holding it in position on this view horizontally, but on our view vertically, because our view's orientated slightly differently. And that basically means that we're going to have to create this slot shape with a center mark. So you can see there that 60 references the center point of this slot. So it means that the slot sketch tool that we're going to have to use will have to be the center point one, which, as I say, I think we used the other week, but one of the other really common ones is that straight slot, but that's not the one that we need for this instance. So center point, straight slot. And then if you hover directly below the origin there, so we switched our planes off in that other feature that we were doing. And at this point, it might be useful to bring them back again. So I'm just going to go up there and click on the eye at the top to bring the planes back again. There they are. And then I'm going to click roughly in the vertical center of this face, so somewhere around there will do. Drag this slot so you can see the center line of the slot is just following my mouse pointer around. So I'm going to set it to be a vertical orientation like that. So you can see the coincident relation visible there, and you can see the vertical relation as well. So the vertical relation is going to apply to the line that runs down the center of the slot, and the coincident is going to apply to the actual point that I'm about to drop. So there, click. And then the third click is just the width of the shape. So I'm going to set it visually to be about right. So somewhere there is fine. And then we don't need this slot tool anymore. So hit escape, have a little look. Yeah, it shaded it in because the slot tool by default creates a closed boundary. So it's already shaded it in. All we have to do is add some dimensions on there. So I think let's try this with the planes on, and then we may temporarily switch them off again if we run into some problems. So the first one, I think we'll do the width. So smart dimension, just put a 10mm width on there. And then this next skill, so this is how it's been dimensioned in the drawing. If we have a look at the drawing, and it's had its length specified as the edge to edge length. And what I mean by that is these arcs on the ends represent edges. So they're arcs, but they're also edges to the shape. And this dimension is dimensioning from the furthest most limit on one edge all the way along the slot to the furthest most limit on the other edge. And if we just get our smart dimension tool and click on one edge and click on the other, that isn't what we get by default. So you can see that even though I clicked on the edges, the system interpreted that as meaning the center point of each one of those arcs. So it's not immediately obvious how you place that dimension. So if you hit escape twice, yes, twice. If you hit escape twice, it's as you're creating a dimension, that's basically you're undoing the clicks on the edges that you just did. So now we're back in the Smart Dimension tool. We don't have any arcs selected. So we're going to do that same sort of procedure again, but we're going to hold down Shift as we do it. So click on the first arc with Shift held, click on the second arc with the Shift held, and then drop the dimension, still with Shift held, and then you can let go of it. So yeah, that's an important one. If you want a dimension to the outside of an edge that happens to be an arc, you've got to hold down Shift to do it. And we're going to do it again in a second, so we'll get another chance to practice it. So this is going to be, is this 50 mil? Yes, this is 50 mil edge to edge, like that. So we're going to do it a second time now, and we're going to dimension from the outermost edge of that arc now. So that arc that forms the end of our actual body of our lever. So we need to hold down Shift as we click on that. So click. And then we're going to go to the center point. So I've let go of Shift now because I'm actually going to click on this little point there, right in the center of our arc. And then if we zoom out again, we should have the dimension that we need. So again, I'll go back and do that again because I tend to lose people at that point. Certainly when I've been in the classroom, I have to walk around a lot at that point and help people. So Smart Dimension tool, and you can do it in either order. You can click the point and then the arc, or you can click the arc and then the point. So let's do it the other way around. We'll click the point first, holding nothing down. Then we'll start to hold Shift down before we click on the arc. And then you can see, as I hover over the arc, the dimension there is the one to the outer surface of the arc, rather than to the center point that marks the center of that semicircle, essentially. So 60 millimeters for that one. And I think we're happy at that point. So fully defined, yep. We've got a closed boundary, yep, it looks good. So I'll click in some free space here to get my exit sketch icon visible again. So that happens if you click off the screen, as I've just did there, onto another window in Windows, that little exit sketch icon disappears temporarily. And then you've got to just click back on the SolidWorks window to activate it again. So we're happy with that sketch, so we'll OK that. And then if we rotate our view round a little bit so that we can see what's going on, yeah, that looks good. And the depth of this, if we bring our reference back in, so there's the depth on that view. So it's just a little 2 mil sort of island that rises out the top face of the part. So set our depth to 2 mil, 2 mil in there, and then OK. So we're nearly there. There's only really 2 features left to put in. So there's some holes which are indicated on our drawing. Where are they? I've lost them now. There they are. So they've got a little annotated hole call out attached to the actual hole on the drawing. And it's saying there's 2 of these holes. They're identical. They're at a diameter of 6 mil, and they go through all. So they go through everything, all the way through. So we're going to put those in. And I mean, what we could do is just read that spec on them and translate that to a circular extruded cut that we put in. But the fact that the drawing that we're looking at here, that was also generated in SolidWorks, has put that annotation on them, suggests to me that the model was modeled using something called the Hole Wizard. So you can see there's a type of feature there called Hole Wizard. And if we hover over it a bit, you get description of what it does in a nutshell. So inserts customized holes of various types. For example, counterbore, countersink, tapped hole, which is a hole with threads in. The type and size of the hole appears in the feature manager design tree. So it's a nice method of, if you're having to put standard sized holes in a part, it's always wise to use the hole feature rather than just doing a manual extruded cut. Or you could even do a revolved cut. You could use a revolved cut to create a countersunk hole. You just have to sketch half of the countersunk profile shape. But yeah, far better to use the hole wizard. And one of the advantages you get with that is that when you come to create a drawing like this of your part, there are certain automated features that you can use that put these annotations on the holes for you. So the system essentially knows that that hole is of a standard size. And on this particular part, it's not immediately obvious, but certainly when you start using tapped holes or holes that adhere to a certain ISO standard or DIN standard or BSI standard, there's a whole table of those stored inside SolidWorks. So it's good to use the hole wizard to create them. So yeah, let's do that. So hole wizard, we've not used this feature before, so I'll kind of go slow through it, and we might go backwards and forwards and just look at some of the options. So hole wizard, we're going to select, and then you get the hole specification dialog on the left hand side. So basically this is broken down into two steps. Step one, which you drop into initially, is what type of hole do you want to create. So you tell the system out of its vast library of standards and hole types which one you want. And then step two, which we're going to go to after we've finished this, which is this tab, where do you want to actually put the hole on the model? So yeah, broadly two steps, but within certainly step one, there's a huge amount of detail. So what I've already said, we just want a 6mm through hole. So that's not particularly exciting, but we will have a little look at some of the other options before we just select our quite boring through hole. So let's just hover over some of these in the hole type. So you have counterbored holes, countersunk holes, the hole that we're going to select, which is just a straight, essentially, it could be a drilled hole. In our case, it's probably molded into the part, given that it's a plastic injection molded part. But that doesn't really matter. You can have a tapped hole. So you can see by this little icon here, it's sort of giving you the method that you'd use to represent a thread in an engineering drawing. So when you represent a thread in an engineering drawing, you tend to just put a little dashed extra line on the outside of the hole diameter. And that kind of indicates that that's the top of the thread form. So the thread form is a number of little spiked teeth, or spiked teeth with the ends chopped off, and they fit within that little gap between the dashed and the actual hole itself, or the actual drill size that created the hole initially before the tap went in. Then we get into some more exotic ones. There are tapered taps, which are often used in pneumatic applications. You come across a lot of these. I think the designation is G, which in Britain at least stands for gas. So a lot of gas fittings have tapered taps. So as you wind the fitting into the hole, it actually tightens up as it gets deeper into the thread. Then you get a whole set of holes that come from the older versions of SolidWorks. So rather than delete them from the system, they've kept them, but you have to sort of delve around in there and define your own sizes and shapes. Then on the sort of last couple of releases of SolidWorks, they've decided to include slots as well. So you can see all those three icons at the bottom are sort of the slot versions of these three icons at the top. So you can have a counterboard slot. So these are useful if you, let's say you're putting a fix in, so a bolt into a tapped hole, but then the thing that bolt is holding down, you want the ability to slide it from side to side. So you want the ability to slacken the bolt off, slide it into a slightly different position, and then tighten the bolt up again. Then you would use one of these types. So you would use a slot rather than a hole. So that's your broad types of holes that the system has a vast library of. The other thing that varies what these actually end up looking like when you put one in your part is what standard you're going to adhere to. So given where this has been taught in the world, we might pick BSI, so British Standard might be useful. Or we've got some imperial standards, so we've got the sort of dominant American one, we've got ANSI Inch, we've got DIN, which is fairly common, ISO I tend to use quite a lot as well. Just lots of different worldwide standards for sizing of fixings and therefore the holes that those fixings fit in as well. Yeah, what else? I don't think we'll go through every single one of these, but we'll have a little whistle-stop tour. So the end condition of our hole. So this is clearly important for what we're about to do. Our drawing specifies through all, so we'll probably just duplicate that when we set our hole up. But these are equivalent to the options that we normally see in our extrude or our extruded cut. So these are just exactly the same. Blind goes to a depth that you then have to specify, so you can see a little depth box appears when I specify that. Through all is self-explanatory and is the one that we are eventually going to select. Up to next, we kind of talked about the other week. So that would achieve exactly the same as through all in this design. It will go to this bottom face and then stop. And then, yeah, up to vertex, up to surface, and offset from surface. I don't think we'll cover right now, but hopefully you can sort of surmise from their names kind of what things they actually do. A few other things. Tolerance. I'm not sure whether we covered tolerances the other week, but we're certainly going to get into them when we start creating a few more drawings. But we'll leave them for the time being. We'll just park that for a minute. The other thing that you can add a manual countersink into these holes as well. So again, I'm not going to go into too deep what a countersink is. If you don't know, maybe do a little bit of reading about holes. Far side countersink is just put a countersink on the other side of the hole. So the hole, if you were drilling it, you'd drill it from a certain side, and then in certain instances you might want to countersink the first side there, and then also put a countersink on the other side. So that's a sort of trickier thing to do if you were machining it, putting a countersink on the bottom side of a hole. But anyway, all those options are available. So let's set our hole up. We just want a straight, essentially drilled hole with straight sides of a set diameter, and we want that diameter to be 6 mil. So we're going to choose that type. And the icon kind of gives us a heads up as to the fact that that is the right type. It's got straight sides. It's just a plain hole. So we'll select that. What standard are we going to use? We'll probably use BSI for this example. BSI is largely metric within here when you're talking about holes. So BSI. What type of hole? So this defaults to dowel holes, which isn't tremendously helpful for new users of SolidWorks, because if you were to create it as a dowel hole, there's sort of an implication there that it's very tightly toleranced. It's a very accurate type of hole, which the one that we're about to create isn't. So it is unhelpful that SolidWorks defaults to that, but you sort of have to remember most of the holes that we're going to create that are just straight holes, we'll just use drill size as a reference as to how we actually size them. So drill sizes. And then if we open this one up, I think I just inadvertently closed this option down, but you can see I'm clicking on it to open it and close it. The size is 6mm. So yours probably isn't set to 6mm. Mine happens to be because I already modeled this part before we began. So you can scroll up and down here just by rolling your mouse wheel. It's probably the easiest way. And you can see there's a pretty vast selection of drill diameters in here. So 6 should be dead easy to find in this list. There it is. Just a straight 6mm diameter drill. We don't want to show custom sizing. That's just if you have to tweak a size slightly. So let's say I had a drill that was labeled as 6mm, but I'd got some micrometers on it and I figured out that it wasn't actually 6mm. It was slightly bigger than 6mm. You can do little tweaks as well. But we don't need any of that. I've already said end condition is going to be through all. So that's kind of all we need to select for this one. It needs to be a plain hole or just a hole. We're going to use BSI. It needs to be defined as a drill size. That drill size needs to be 6mm diameter. And the end condition needs to be through all. And that's it. So none of these options needs ticking. You don't have to play around with these options. So we've specified the hole type. Now what we're going to do is we're going to place the hole or the pair of holes on our model. So there's our model. So I'm going to activate the positions tab. So you specify what the hole is, then you specify where you're going to put it or where you're going to put them, because we're going to put 2 holes in within a single hole feature. So it's asking you a question, as we've seen before. It's highlighting the question in yellow, saying select the face for the hole or slot position. So essentially, if these were going to be drilled, we would drill them from this side. So we are the point of the drill now. We are looking down at the part. We are looking down from the perspective of a drilling head or a milling machine down onto the part. That's purely a decision I've just made. And the reason that that makes sense is that we want to center these holes in the center point of these arcs here. So it wouldn't make any sense to try and drill them from this side of the part because you can't easily see your reference geometry that you want to relate them to. So far more sensible to drill them down from this side. So that is why, in answer to this question, I'm going to select the top face of that island that I made there. So click on there. The system will auto-rotate my view because I've set that option now, that auto-rotate option and auto-normal too. Then what I want to do, I want to hide the base planes because what I'm going to do, I'm going to get the system to show me the center point of these arcs, and it's a little bit obstructed by the fact that that plane is still visible. So I'm going to temporarily hide the planes. So I'll click there. Planes will disappear, and then before you click, just hover over these arcs on the ends of these slots. So you might have to sort of go to the arc edge a few times before the center point becomes visible, but trust me, it will. So if you sort of hover over the arc for long enough, the center point of the arc becomes visible. When it does, you want to click, and that will drop a copy of your hole type in that position. So hopefully it's now locked just using relations into the dead center of that arc there on that end. And then I'm just going to do it again on this end. So if I hover over that arc for long enough, the center point becomes visible, and then I can click right on that center point and the system will add a coincident relation. Then you can see what's happening. So every time I click, the system drops a hole. So you can see they're previewed there as yellow geometry. And then it offers me up another hole. So you can see there's one following my mouse pointer around here now. There's a third hole offering to be sort of inserted into the part. At that point, I'm happy and I don't want a third hole. So I can just go up there and click on the green tick. So I'm happy with the two that I've placed. I don't want to place another, so don't make the mistake of clicking again. If, however, you did click again, don't worry, you can hit escape, because I don't know whether you've noticed, but we're just in a sketch. You can see the sketcher toolbar active at the top there. So the way that holes get placed in the hole wizard feature is the system is just sketching a single point. So the three holes that have been placed there have a single sketch point in their center. And that's all the system is doing. It's just dropping single points every time I click. And you can see there, the point tool is actually active. So if I wanted to not drop anything more, I could hit escape and the point tool is now inactive. So in the same way that when we get the line tool and we don't want to draw any more lines, we hit escape and we get out of the line tool. If you do that as you're placing holes, it cancels the point tool. And the reason I've done that is I want to click in some free space over here, and then I want to click on that center of that hole that I don't require and just hit delete. So we're just in a sketching mode, as we often are when we're creating extrudes or extruded cuts or revolves or revolve cuts. That's the way that the system places your hole types. So you set the type, then it drops you into a sketching mode, and then all you're doing is just inserting points, and it uses those points as the position to put your type of hole. So yeah, it's not an alien concept. It just handles it in a very similar way to the other features, but it's literally just dropping points into a sketch. Anyway, so we're happy with that. We can exit the sketch. So we click on the green tick this time up here. And then we come all the way out of the feature, because that green tick was essentially OK the entire whole feature. And then the holes should be in the correct position. And if we rotate round, we should see that they're passing all the way through the part as well. So that should be what you end up with. And then if you just have a look over at the left-hand side, it's put the hole wizard feature in, and it's given it the correct name as well. So this was one of the other advantages. It kind of names these holes correctly, so it knows that that was a 6mm hole feature, so it calls it a 6mm hole feature, which isn't that spectacular in this instance. But if you create an ISO tapped M4, it will name it properly. It will say what standard it comes from. It will call it an M4 tapped hole, so it's quite useful. And by far the best way of creating holes in your actual part model. So we're almost there. Let's keep going, and we should finish this part in this session. So the last little bit is this extruded cut shape down at this side. So you can see on the 3D view there, someone's asking about uploading the recorded vids. I'll just read this chat. Hold on. When I upload the vids, upload them onto there, because you can skip back and forward and adjust the speed. Yeah. Really struggle watching the 1.5 hour. Yeah, I can do. That's not a problem. I haven't before, so I'm saying yeah, I can. But I don't see any problem in that. I can do that. That's no problem. And if all else fails, I'll just upload them onto YouTube, which has got speed controls as well. So yeah. But yeah, the short answer to that is yes, I will. No problem. So the last bit of this design is this extruded cut on this angled face on this end, which, if you have a look at this aligned view here, which is essentially viewing the part from that direction. So you can see on drawings, and this is one of the things that we're going to look at when we create this drawing, you can add a view which isn't a projected view particularly. So you can see this view here is sort of projected from this view here, and in a sense this section is you can kind of regard it as a projection as well. But this one is just an aligned view, and the direction that it's viewing the part from is indicated on that arrow that's got an A label at the side of it. The reason I'm saying all this is that the shape of the slot is referenced relative to that face. So when we create this cut feature here, we're going to have to be sketching on that face, or at the very least on its reverse counterpart on the other side of the part there. So I'm just trying to break these features down in my head and try and come up with a plan of action as to which face you're going to have to create the initial sketch. So anyway, we've already said we're going to create it on this top face here. So extruded cut. We know how to activate the extruded cut. You click on the icon. What face do we want to sketch on? We've just discussed. So we're going to click on that face. The system will now rotate my view around, so that's quite useful. And then we may be better off referencing my screenshot that I made earlier for this one. So there it is. So that screenshot is in the same orientation as what we are seeing on our screen. So I may use that as a reference rather than the drawing, which is spun through 90 degrees. Well, a little bit more than 90 degrees, which is hard to rotate it in your head as you're drawing. So what are we going to do first? Let's get the line tool. So line tool there. Let's pull that off to the side a little bit. And then we're going to sketch out this rough shape. We don't have to be too accurate with it to begin with, because we're going to add dimensions and add relations to it just to get it looking as it should be. So I believe the first point is locked to. So this is why the order that you create these features is relatively important. So I believe this first point that we're about to drop in, which is that one on the sketch, that one right there, is locked to the point at which this fillet feature, so that fillet that we put on that edge earlier, must be there first, because we use its endpoint there as a reference to lock our sketch to now. So it would have been no good if we'd have created this cut first and then put those fillets in second, or put those fillets in later rather. The fillets must exist first because they're a reference for the position of this actual cutout. So yeah, that's a good example of why the order that you create the features in is critical. So it's worth taking a little bit of time to sort of think about it. But anyway, so we can hover over the end of that fillet. You can see it tapers down to a point, and you can see that point being highlighted in orange there. So when you're over the top of it and you've got the coincident icon, you can click, and then I'm trying to match that screenshot that I'm looking at on the left hand side, so we'll click about there. I've gone too far there, but that doesn't matter. And then as I try and sketch this bottom edge here, you can see as I get near to being parallel with that first edge, it offers me a parallel relation, which is that looks like an equals, but it's angled slightly. And in this case, I want them to be parallel, so I'll allow it to put that relation in. You can see it's added it there in green. And then I want to go to here, and then this edge does not want to be parallel. But it wouldn't be the end of the world if I let the system put the parallel relation in. I wouldn't get too sort of obsessive about that, not having that one in, because we know how to delete relations now. So I go back to the start, and I've created a closed boundary. Now let's go back in and do that deletion, just as a practice. So press escape to get out of the line tool. Find the relation that you want to delete, so it's that one there. If, again, just to recap how these work, if I hover over the icon, not only is it numbered in pairs, so you can see there's a number 3 after that one and a number 3 after this one, which means they're paired together. Also, when I hover over the icon, the two edges or the two entities that it relates to both glow in that sort of pink magenta sort of color. So yeah, that's the one I want to delete. So I click on it, press delete, and it's gone. So yeah, it's easy to get rid of them, as easy as it is to add them in. So I'll put some we'll put some dimensions on this first. So smart dimension, let's put the angles in. So you can see that there's an angular dimension between there and that edge. Now, in reference to what I was saying earlier about things that you create references to may change. If somebody redesigns the part, this edge might technically not exist anymore. So I'm sort of taking a risk by using it as a reference to set the angle of this sketch, but it's a known risk. But it's worth mentioning that. Probably a safer method to do this would be to try and reference it to a base plane. But given that we're sketching at a strange angle here, we're on an angled face, it's not easy to relate that back to the base planes. So that's kind of why I'm using this edge in this instance. So yeah, let's use that edge. Let's drop that dimension or that angle. And that one is 35. So, and then when it changes, you can see the actual position of the angle dimension moves a little bit. So it might be worth kind of dragging it back to where you want it. Then I'll do that again. So I've still got the Smart Dimension tool active. Click on that edge. Click on that edge there. Drop the dimension, 25 for that one. Then we've got a 31 along that edge. And then a 26, which comes from that edge on the part and goes up to that point there. So that's 26. So that's all the dimensions added, but our sketch is still free to move in some way. So again, we'll investigate that. We'll click and drag like we've done before. So that is free to move about in a sort of horizontal sense, although it's been constrained to be stuck to the end of that 35-degree line. And I suspect this edge is free to do the same. So we're missing something here, and the thing that we're missing is the midpoint of this edge needs locking to that plane that we decided was going to run down the center of our part. Which again, this is sort of forethought. It's thinking, is there a line of symmetry running down some of this part? Yes, there is. Right. It's quite useful to have a plane running down that line of symmetry then. Yes, it is. So again, it wouldn't be the end of the world if that initial extruded boss base had been done in a single direction, because what you could have done at this point is just temporarily got out of this sketch and gone back in to that original feature right at the top of the design manager there and edited it slightly and switched it from a blind to a midplane. So all is not lost. If you don't make quite the right choice in the first place, you can always get back into these features and tweak them slightly and change them. Someone's just asking for the other vid as well. Yeah, I'll upload them both. If we're going to upload them to there, I'll do the ones that have already been uploaded as well. Don't worry about that. So back to what we were doing. So what we want to do, we want to make the planes visible. We want to then hover over this line here till the center point pops up. Click on the center point. So we've got that selected. Hold down Control. Click on the plane and then put a coincident relation between the two. So that's half corrected the problem. Have I missed a dimension on here? Aha, I know what's going on. Okay. So the assumption, now that we've done kind of everything that we can do and these edges are still free to move, and on the drawing there's still no particular reference to how wide the slot is, then you kind of got to make an assumption now and say, I'm going to assume the slot is as wide as the island there. There is no other explanation. And lo and behold, I've just noticed there is an actual set of construction lines here shown on this view. So you can see the intention is this extruded cut slot that we're about to create, or extruded cut shape, is exactly the same width as the island in the center of the part. So we can put a relation in between those two. So here we go. So I think I'll get a point on the end of one of these edges, so that point there is as good as anything else. And then I'll hold down Control and click on that edge of the island that I made. And then it's a coincident relation. So basically the system regards that edge as infinitely long. And the point that I've just selected can be made coincident with it. Like that. And that's it. Once you put that last relation in, the sketch is fully defined and we're ready to OK it. So click on OK to get out of the sketch. And rotate your view around a little bit so that you can make sense of what's going on with the extruded cut. And then all we have to do is set the depth to something sensible. Now, given that this is sort of pointing a little bit more towards the rest of the part, because it's coming from this angled face, I'd be tempted to set it as an up to next, rather than a through all, just in this instance. But yeah, you can always come back in and change that if it's inconvenient and you need it to go through more than one face. You could change it to through all. But yeah, we'll have it as up to next for the time being. Click on OK, and we should have completed the part. So we'll just have a quick inspection. That was what we were aiming for. It looks as if we're there. I think, yeah, pretty good. Okay, right, so the next bit, what we have to do is we have to save a copy of this, because we're going to create a engineering drawing from it. We kind of need it saved already. If for no other reason, when we come to drop back into the engineering drawing creation, the system needs to know where it can find this part file. Otherwise, any drawing that you create in SolidWorks, so any engineering drawing, must know where the part file is located. So you can't create a new engineering drawing and then delete the part file or move the part file to a different folder, because the system will refuse to open the drawing. It will allow you to open it, but the views that you create of the part will all be blank. So just a word of warning. The second word of warning there is, if you are going to create part drawings that are of parts, keep the drawing and the part in the same folder. It just simplifies everything. It's not 100% necessary. You can set SolidWorks up so that all your parts sit in a certain folder and then all your drawings sit in another folder. And as long as each one knows where the other folder is, everything is fine. But it just overcomplicates things at this level. Just keep all your parts and all your drawings in a single folder. Just dump them all in together. And yeah, you'll not run into any problems in terms of drawings not being able to find their corresponding parts. So let's take a save of that. So the save icon is at the top there. It's that old style floppy disk looking thing. Click on that, navigate to a folder that you're going to keep all these things in. Now, given that I did this earlier, I've already got a copy of this part, so maybe I'll save this one with the number 2 at the end. So tire lever 2. I don't really care what you call it, but yeah, give it a name that seems logical. Then what we're going to do, I think, to better simulate the process of creating a drawing, we'll probably shut this part down. So we've taken a save of it. Now I'm going to click on that X at the top right of the just the graphics window. So there. So you should be looking at that sort of screen. So what I'm trying to simulate here is, let's say a scenario where maybe you created a part on a different day and then you're coming back into SolidWorks to create a drawing. Or maybe one of your colleagues has made a part file and they've said, can you just do me a drawing of that? So whereas if we'd have kept that part open in the background, what SolidWorks does is it assumes that that's the part that you want to create the drawing of. So it sort of skips a step at the start of the process that we're now going to have to do. But this is, because you're just learning, this is the sort of safest way of teaching you how to do this. So new file, sorry. So it's the paper icon at the top again. This time we've already said it's a drawing that we're creating. So if you want to double click on drawing, and then because we've got no part open, well, we'll go through the drawing setup first. So again, you might not be seeing exactly what I'm seeing. So you might have this box selected, only show standard formats. And when you came into SolidWorks initially, the other week, when you just set it up, you may have selected that you wanted to use the BSI standard. So that's the standard that I told it I wanted to use initially when I first installed SolidWorks. So that's why my system, when I have that box ticked, only shows me the sheet sizes that are standard in BSI. Now, I don't want to be constrained to just those, so I'm going to untick that. So when you untick that, you should see every standard that SolidWorks has stored. And if you click through them, you can kind of see a little preview on the right-hand side of what each one of these drawing sheets looks like. And I think the one that we'll use for this example is ANSI Landscape A4. So I think that was what this was created on, this drawing. So that's going to be the one that we're going to use for this. But just be aware that there's lots in there, and you can even have your own. So I've got my own saved at the end, and we may have a look at creating our own drawing templates eventually. But back to what we were doing. So what did I say? A4 ANSI landscape is what we want. So we'll click on OK. It drops us into a blank sheet. So it's given us the standard ANSI A4 title block down here. And it's given us the standard ANSI A4 border as well. And all the text that you get about dimensions are in millimeters in that standard, and all the sorts of things that you'd expect on an engineering drawing. But what we need to do first is we need to tell this drawing what part file we want to make a drawing of. So given that we've not got a part already loaded up in the background, we need to point it at our folder that we just saved our part into. So you click on Browse, which again is reasonably self-explanatory. You want to browse around on your computer to try and find the part that you want to create a drawing of. So I'll probably use my one that I had created before the lesson. So tire lever, there it is. Now, my system automatically dropped into the folder that I just saved my part in, which I think yours should do the same. I think that's the default behavior. But if it isn't, you can browse around your own computer and find the folder where you saved your part that we just created. But there's mine. Click on Open. And then what it does is it okays that set of menus that we were just in there close, because they've essentially been okayed or ticked. And what it does, it takes me into this menu here down the left-hand side. And what that is, that's the dialog or menu for placing views of your model or views of your part. So there's a few options that I have on in there that you might not. The first one being this preview option. So I would switch that on. And what else do we want to do? So what I'm doing, hopefully you can tell here, I'm looking at the tile lever from the end that we created, that sort of last feature, that diagonal cut that we put in the end. We're now viewing the part from that end. So that's not the first view that I want to place. If I get my reference drawing, I want to place this view here. So this, what I'd consider the side view, I want to place that on my drawing sheet. So what I have to do is browse around my standard views of my part, and here they are. So if you hover over these, you get a little pop-up that tells you what they're called. So I'm currently viewing my part from what it classes as the front. So if I go to this one, the right, let's see if that, yep, that's the orientation that I want to view it in. So if I click somewhere on the sheet, which again, from our reference, I want to click sort of here on the sheet to drop this view. So I'm going to do that. So I'm going to click. Then what happens is I get a projected view. So don't click again. Just move your mouse pointer around and see what's happening. And hopefully you can see that wherever I move away from that original view, I get a view which is projected away from it. So what I want to do, I want to drop a second view there. So I'm going to click again. And then that's it. At this point, I don't want to drop any more views onto my drawing sheet. So I'm going to either hit escape or click on this green tick over here to get out of that menu. So a few things to say here. So this was our reference image. And hopefully, if I can get both of these visible at the same time and just size them properly. There we go. That's sized. So we placed this view first, and then we projected this view away from it. And as we projected this view, it got projected in what's known as a third angle projection. Whereas the reference image that we're working from, this was the initial view again, same as the one that we placed, but then this view was projected away from it, which is a slightly different method of projection. This is known as first angle projection. So the drawing that we're about to create, again, given that this lesson has been taught from Britain, we want to use third angle projection because it's the one that we tend to use in the BSI system. But it's worth noting, we're not going to create a carbon copy of this drawing because first angle's been used in this drawing. So we're going to project upwards and get the same view, whereas this one's been projected downwards and you've got the same view. So ours is slightly reversed. And if you need to change that, because I'm aware that often SolidWorks comes set up for the US market, and the US market would use first angle primarily. So if you wanted to change from first angle to third angle projection drawings, you can do that really easily. The way that you do it is you go over here and you change something about the drawing sheet itself. So you right click on the word sheet 1, right click, go down to properties, and that will allow you to set things such as the drawing template. So that drawing template that we set initially is listed here, A4 landscape inside the ANSI folder. You could change that if you wanted. You could change the overall scale, and you can change first angle to third angle and back again. So you can see there's just two little buttons there, and you either have it set as third angle or first angle. Which again, I always find it difficult without a visual reference to explain the difference between these two. But yeah, have a little type into Google after the session and hopefully there'll be a nice little animation and graphic to show you the difference if you don't know it. But it's just the method in which you project views away from a sort of initial view. Yeah, so that's how you would change it. And that's how you'd set yours up into third angle if it was set as first angle instead. Now then, basic navigation in here, I think, is all we're going to cover this week. And then we're going to take a save of this drawing and we're going to come back in and hopefully create something that's going to look more like this next week. But yeah, basic navigation. So let's say you wanted to delete a view. Let's say I want to delete that view. I can. Now, you tend not to click directly on the model when you're doing these. It's better to click on the little box that pops up when you get near the model. So you can see that there's a little orange box that pops up. It's easier to try and click on the box than it is on the actual model itself. So I can drag these around. If I click and hold, you can see I can drag a view around. Now this view that I'm dragging, because it's a projection of this view, I can't currently drag it left and right. It won't let me. And that's because this view is the master view, and this is the child, or this is the parent view, and this is the child view. Essentially, this one came first, and this one defines where that one gets placed in a horizontal sense. So you can see the behavior there. So have a little sort of drag around, see what the behavior of it is. And if I was to try and delete this one that came first, it then says that this one has been essentially orphaned. It no longer has a view that it's projected from. So it becomes its own view then. So yeah, it's just the order in which you create them is sort of critical to how they behave. So yeah, that's the gist of those. If I wanted to create another projected view from one of these, I can. So the way that you would do that is just, if you click on the view, so you select the box that surrounds it like that. So click. And then of the quick access icons that pop up, there's one that is project view or projected view, which is that one. So if you hover over it, you'll get the little tooltip visible. So click on that, and then you get that same sort of behavior that we saw initially, where you could project another view. So if I click there, I get another projection and another projection and maybe a 3D projection up there. So we know how to sort of add more projected views in. The fact that it's this one that's controlling the positions of all those. Now they have a degree of freedom as well, but they can't come out of alignment with their sort of parent view that created them. So yeah, that's the sort of broad concept of projecting views from an initial view. So I don't want this one, so I'm going to delete some of these. I'm going to click on the box around that one, hit the delete key, OK the deletion, do the same with this one, delete key, yes. And then, so what do we want to do next? Let's put the 3D view in. So the 3D view at the top right here, let's insert that one. So you saw when I was projecting views, I could have projected sort of an isometric 3D view from here. But really, if you're putting these 3D views in, which you tend not to get them in traditional hand-drawn engineering drawings, just because they're really difficult to create. But in modern CAD-generated engineering drawings, such as this, it is a nice extra bit of information to sometimes drop in. If you've got space and you can fit one of these, maybe in one of the corners, it's a nice extra view just to put in, just so that people can quickly sort of assess what is this shape, what is the form of this part, and they get just a quick load of information from that view. And then they can delve deeper and look at the actual details. So yeah, the point of all this is it is nice to be able to move this view independently of all the others. So to place it wherever's convenient for you. And for that reason, I would tend not to project it from a parent view. I would insert it in its own right. And the way that you do that is on the toolbar at the top there. If you have the drawings and the drawings tab active, you can just select model view. And if you click on that, you get back to where we were initially when we dropped this view in. And it basically asks you, it says, what parts do you want to create a view of? So we only have one part kind of loaded into memory at the moment, and it's the tire lever, so that's why it's showing us it there. If we had multiple parts open in the background, they would all be listed here. So you could make a drawing that showed 2 different parts. I don't recommend it because you confuse people, but you could. So tire lever is what we want. Click on the little next arrow at the top. And then again, we're familiar with this now. This is where we came in, where we were selecting views of our part. And then if we hover over the window, you can see we're getting that initial view that we had when we first came in. But we don't want a flat view. So we don't want a front, we don't want a right or a top or a bottom or a left or a right. We want this one, isometric. So if you click on that, you get a 3D view, and then you can click to drop that. And then if we really wanted to make it appear as this one appears, there's a couple of things that we need to do. So we need to change it from a line model to a shaded sort of style, which we can do relatively easily. And then we need to rotate our sort of perspective where we're looking at it from as well. So we need to do sort of a 3D viewpoint rotation. So we'll do both of those things. So first one, let's switch it to a shaded style of view. So again, if you want to select it, make sure you click on the box around it rather than trying to click on the actual part itself. So click on the box around it, and then over on the left, there's everything about this view that you're able to change within the system. And one of the things here is display style. So again, we sort of touched on this. You get these same icons available to you when you're creating your part. You can set it as wireframe, for example, or you can set it, as we've just had it, as hidden lines removed, or you can set it as shaded with edges, that's exactly what we want. Shaded with edges. You can have it shaded without the edges defined as well, but that's less clear in my opinion. So shaded with edges. So we've set the type of view. Now we want to rotate our viewpoint. So we still have the view selected there. You can see that the box around it is highlighted in blue. And one of these icons at the top will allow us to rotate our 3D sort of perspective. And it's this one. So if you hover over them, there's a rotate one, which you don't want to get that by mistake. All that does is it just turns the view through a number of degrees. We want this one, 3D drawing view. So we'll click on that. And then what you can do, you've essentially got a little window there that if you click with your left-hand mouse button and drag, you can just drag your viewpoint around the part, almost as if you were in the part modeler again. So in the same way that you can drag your view around in the part modeler using the middle button, you can drag your view around here just using the left button. So when you're happy, I think something like that is the viewpoint that we want. You just click on the tick and it okays that. So pretty simple to set up. And then one last thing. So say the overall sheet scale, which I'm just zooming in on here. So our overall sheet scale is set at 1:2. So things are drawn at half size. You can specifically size one of the views different to the rest. So maybe you're running out of space and you want to size this view down a little bit. Again, as a general rule, if you select a view, the menu that comes up on the left governs all the properties or all the different things that you can change about that view will be available to you on the left there. And with a little bit of searching, you can see there's one that's titled scale, and it's currently set to use the same scale as the entire sheet, which, as I've already said, is 1:2. But if you want to set this view as something that isn't that, you just select custom scale. So again, you can sort of figure these things out a little bit by trial and error, but it's all quite logically set out. So 1 to 2, let's say we want to go 1 to 3, you just overtype this value. So 1 to 3, press enter, and the view changes. Or maybe you want to go the other way and go slightly bigger. Maybe we could have 1 to 1 for this view. And you can see the effect that that's having. So again, anything really that you need to change about any given view should be available over on the left here when you get the view selected. So in this instance, we're not going to set this scale to a different value. It's just to illustrate that you can. So I'm going to set it back to use the scale of the sheet itself. So how are we doing for time now? I think if you take a save at that point, so we've done the basics there, and we are going to come back in onto this sheet, and we will add all the other view types in, and we're going to put some dimensions on this thing as well. Maybe change some of the sketch line colors. And I think what's not shown here, but we will have a look at as well, is we'll look at creating our own title boxes and borders as well, because that's quite useful. So yeah, make sure you take a save of that. So mine's just disappeared. Just give me a sec. There we go. So exactly the same procedure to save it. There's that save icon on the top menu bar there. So if you click on that, and then it might ask you, do you want to update the views? Yes, you do. And then what it'll do by default is whatever your part file was called, it will call the drawing exactly the same name. And I suggest you accept that, because what that does is it allows you to sort of pair up a part with a drawing quite easily. If you're quickly looking through a folder, you can see the drawings that go with each part. But you won't get a conflict because it just puts a different extension on the end of each. So drawings are known as SLD for SolidWorks, DRW for drawing. So SLD, DRW at the end for a SolidWorks drawing. And then SolidWorks parts are SLD, PRT. So they can both have the same name before the dot, and then it just puts a different extension on them, that's all. So I'll probably oversave mine because I saved one earlier, but I'll save this one over the top of it. So I'll just click on yes. So yeah, I think we'll leave it there for this one. And I will upload those videos onto that other service. What is it? Where is it? Yeah, I'm going to take a copy of the name of it just so that I can remember that. Yeah, so I think we'll come back and we'll keep going with that next week. So has anyone got anything else to raise just before I sign off? Is everyone okay? We'll reconvene next week. I think we're all good. Yep, all good. Very good. Okay. Yeah. Make sure you've saved those files somewhere where you can get to them easily next week. And yeah, we'll continue on then. Okay. Bye.